Hello, everyone. Welcome to another episode of Northern Lights, Canadian Women in Tech and Business, where we highlight the incredible journeys of inspiring women who are shaping the future of technology and business in Canada. Today, we have the honor of speaking with another trailblazer, Dr. Nandita Vijaykumar. Dr. Vijaykumar is an assistant professor in the Computer Science Department at the University of Toronto and the Department of Computer and Mathematical Sciences at the University of Toronto Scarborough. She's also affiliated with the Vector Institute for Artificial Intelligence and the Robotics Institute, where she leads the MARC research group. Before joining the University of Toronto, Dr. Vijay Kumar was a research scientist in the memory architecture and accelerator lab at Intel Labs. She received her PhD and MS in 2019 from Carnegie Mellon University, where she advised by Professor Anar Matlu and Professor Phil Gibbons. She also collaborated with the systems group in the computer science department at ETH Zurich as a visiting student. Throughout her career, she has gained valuable experience working with leading companies such as AMD, Intel, Microsoft, and NVIDIA. Dr. Vijay Kumar's research interests lie in the general area of computer architecture, compilers, and systems, with a particular focus on the interaction between programming models, systems, and architectures. She fosters collaboration with relevant departments, the Vector Institute for Artificial Intelligence, and the Termini Center for Artificial Intelligence Research and Education in Medicine. Dr. Vijay Kumar, thank you so much for joining me today.
Thanks for the great introduction, Berlin, and very happy to be here.
Thank you so much for joining us. So maybe we could start off by you sharing your journey into the field of computer architecture and systems and what motivated you to pursue a PhD at Carnegie Mellon University.
That's a great question. And like most people I know, it wasn't a very linear trajectory, I would say. I certainly did not believe that this was going to be my trajectory when I was in high school or even doing my undergraduate studies. But somehow I found myself here. And to give you a little bit of a background, my initial goal was to go to med school, which I did. And then unfortunately, I found that that is actually not for me. So I dropped out very quickly. And then I switched focus and specialized in electrical engineering to start off with. And I enjoyed that quite a bit, but it still wasn't something I found interesting enough to pursue as a part of my career. So then after that, I had the opportunity to do a PhD in more computer science related fields, which I found was a great fit. And at that point, I got quite excited about the research that I was doing and the impact that it could have. And that's basically what got me into the whole trajectory of computer science and doing research in computer science. I think for me, the most exciting part of all of it is the impact that it can actually have. And especially, this has been true for a while with computer science, but definitely true now. It's very easy to see the direct impact that it can have and how you can use it as a means to change people's lives, solve exciting problems, and to be a part of that whole movement. And I found that quite interesting.
So great to hear about your journey and, seeing your true passion take impact, like you said, is just really incredible. So during your time as a research scientist at Intel Labs Memory Architecture and Accelerator Lab, what were some of the key projects and insights you gained?
So once I completed my PhD, before I started my faculty position at the University of Toronto, even though I had already accepted an offer, I took, I suppose, what you may call a gap year to spend some time. It wasn't really a gap year because I was still working, but to spend some time in industry. And in this case, it was at Intel, just for less than a year. And in this particular team and company, I had the opportunity to work on a very important part of the computer system, which is memory, which is where all the information is stored during computation. And in today's processors, memory is a huge bottleneck in terms of the type of applications that you can run and how fast you can run it. And I was able to do some, I think, pretty cool research on addressing some of those challenges at that time in a leading company. And that was a very valuable experience.
Yeah.
And we were able to complete a project, and we have published papers during that time as well. And it was a fun time.
Yeah, that's wonderful to hear. And, just learning about, one of the many roles and responsibilities you have. You are an assistant professor in both the computer science department at the University of Toronto and the Department of Computer and Mathematical Sciences at University of Toronto Scarborough. Can you describe your roles and primary responsibilities in these positions?
That's a great question. So this will be quite similar for most folks and most faculty in these roles. At a high level, my responsibilities, I would say, are you can put them in, let's say, three buckets. The first is teaching. Teaching graduate and undergraduate courses. So that's a very fun part of the job. And for example, for my graduate course, I got to construct a course based on my research interests and expertise. And then an undergraduate course would be more fundamental. So that is what you would expect, obviously, teaching as a part of the job. The second one, which takes up quite a bit of time, is for me, the most exciting part is the research. So I lead a research group with some fantastic students, PhD students, master's students, and undergraduates. And like you said, my research group is called Embark. It's kind of a play on embarking on a journey of research as well as on architecture.
Hmm.
So we do, I think, pretty cool research on accelerating and making more efficient systems for various applications such as computer vision, deep learning, and robotics, and also designing more secure and privacy-preserving systems. So a lot of this involves mentorship and driving the research with my PhD students. Of course, my PhD students do all of the work, but it's exciting to work with them and drive those efforts, as well as just managing the group and making sure that my team has all of the resources that they need to do great research. So I would say that's the most exciting and fun part of the job. And then there's the element of actually doing some of the service, which is helping do some of the functions in the department. And most academics are also quite heavily involved in running conferences, academic conferences, and so on, which requires peer reviews and things like this, which also is a part of the job.
Yeah, that's really great to hear about, all the amazing work you're doing and that you're enjoying it so much. Your students must learn so much from you. I could only imagine.
I
Um,
hope so.
yeah, oh my God. Um, so what are some of the key research ideas and current projects you're focusing on, as the leader of Embark Research Group, at the Vector Institute for Artificial Intelligence and the Robotics Institute?
So overall, my research group, I would say you can say there are two large umbrellas in which I would put our current research. So one is in general making faster and more efficient systems, and by systems I mean both actual hardware processors as well as software systems on top of it to make some kinds of applications like 3D vision. And I'll talk in a second about what these mean, robotics, computer vision in general, to both make them faster, cheaper to run, as well as possible to run on smaller devices. For example, something that doesn't need a whole data center and something that you can run on a mobile robot, which will enhance the compute capabilities that we can do today. So one of the key challenges of a lot of, let's say, the latest applications and running them is that they're very compute intensive, which means you need a lot of very powerful processors. GPUs are an example of this, and other types of processors to really run them. And this is a challenge in a number of ways. One is that it's going to take some time, which means these applications don't scale. We need more and more time to be able to run these applications. And sometimes we want instantaneous responses. Robotics is a great example of this, where if you're trying to navigate or make decisions very quickly, you want to be able to do this really quickly, all these computations, anything interactive as well. So speed is one of it. The other is just the computational expense, right? So a lot of these processors are not cheap, and to be able to run applications on them for days or longer can be quite expensive, right? And they're also extremely power hungry. So data centers in the world take up a huge fraction of the overall energy that we are burning as a planet. So and it's something that we need to definitely work on. And all of this requires just more efficient computation, more efficient systems that for these applications. So we do quite a bit of research in this space, and I would say the nice thing about our group is that we do this across the stack, which means at the hardware level, which is just designing processors that are more efficient. So this is what computer architecture is, but also at the higher levels, for example, just designing better or more efficient algorithms and software systems that actually run these applications on the hardware as well. And another broad thrust that we are interested in also is in privacy preserving deep learning. So deep learning is extremely popular today, and there are many different use cases for it, from ChatGPT to recommendation systems to many other use cases that you'll find on your phone or in many other applications. But it's a lot of them involve using sensitive user data, both to train them, as well as when a user interacts with these systems, right? So if you want to ensure that the user's data is protected sufficiently, then there are additional algorithms that you need to add on top of them, and they can often be quite inefficient. So this thrust is essentially looking at how we can enable more efficiency in these privacy-enabled systems so they can be used more practically. So that's another broad area that we do research in.
Thank you so much for that answer. You made some, really great points there. And I'm really curious to hear more about how did your collaborations with leading companies such as AMD, Intel, Microsoft, and NVIDIA influence your research and career?
That's a great question. And one of the reasons that I really enjoy computer science is that many aspects of it are quite, I would say, applied and relevant to what all the tech companies are doing. So especially the areas that I work in. So it's important to work closely with industry for a number of reasons. One is that to make sure that you're aware of the challenges in this space and where the field is moving, right? So you can help address some of the challenges in the future. And the other is you don't want to be doing research in the dark, right? You want your ideas to have some impact and some influence. And the best way to do that is to work with tech companies. And this is basically what I've done throughout my academic journey, both during my PhD with internships and now with various collaborations. And the nice thing about all of these tech companies is that they also often recognize the importance of academia. So they have various programs which you can actually work pretty closely in terms of both tech transfers as well as creating new big projects that you can work on together and so on.
Yeah, that's wonderful. And I think that leads perfectly into my next question, which is your research focuses on the interaction between programming models, systems, and architectures. So, can you explain the significance of this interaction and its impact on advancing technology?
That is actually a great question. So I would say in the past, there was still a lot of this interaction, but not as much as uh, you see today. And the reason for this is one of the key methods that people have used recently to gain significant advances in the performance of processors is actually with specialization. So what this means is that while in the past we had more general purpose processors, which means that regardless of the application that you were actually running, the processors and the software systems under it, there may be some variations, but overall it was more general in the sense that they were quite similar. Whereas today, things are becoming more and more specialized. In other words, for the important applications, the way that we're able to gain significant performance benefits is by actually designing entire hardware and software stacks just for these applications, right? For example, if you look at the deep learning applications, we have now a range of different both hardware accelerators that are designed just for these applications, as well as the compilers and programming models on top of it that are also specialized for these types of applications. And this gives us huge gains in energy efficiency, in performance, and in some cases also cost. So all of these this direction in which we've sort of been evolved in for these reasons mean that the interaction between these levels of the stack have become a lot more important and relevant. So that is, I think, one of the things I enjoy as well.
Yeah, I fully agree with you there. And again, you made some really, really great points. And I'm curious to know, just looking ahead at the future here, what do you see for the future of computer architecture evolving, especially in relation to AI and healthcare applications?
That's a great question. So for me, I find computer architecture a very interesting and exciting field. I have felt this way for quite a while, and I think it continues to be so. And one of the um, reasons, or the primary reason why, is computer architecture involves the design of processors, essentially. And processors enable computation, or they enable the applications that can run on it and the scale of them. So an example of this is a huge part of how we were able to run deep learning applications is because of the availability of compute that allowed us to process so much data
Mhm.
at a relatively fast. And now we are in this phase again where the applications are getting more and more compute intensive. We want to process more and more data. The applications are getting bigger. And to enable all of this, we really need faster processors. And having better technologies for this would enable more powerful applications and more powerful capabilities. So in that sense, computer architecture continues to be a very exciting enabler for these applications in AI and beyond. And I think the future there is could be integrating new technologies and new paradigms that will take us to the next level. This could be anything from new memory technologies that gives you more reliable or faster memory systems to completely new paradigms like quantum computing and so on.
Mhm.
And these are some exciting directions that the whole field could take in the future.
Yeah. Yeah, that's great to hear. And I know I'm, really looking forward to seeing what the future holds for AI. Um,
Go
yeah, so
ahead.
What advice would you give to young women and aspiring researchers who aim to make a significant impact in the fields of computer science and AI? And do you think there's any particular challenges you face that they should be aware of?
That's a great question. So maybe I'll start with the challenges first. So I think one of the challenges that any new researcher in the field will encounter is that computer science now is extremely fast evolving. So it takes a lot to be knowledgeable about the state of art in it, and that changes all the time. So that is, I would say, quite a bit of a challenge. So it's it may not always be so straightforward to directly dive into um, especially if you want to do research in these, it may take a while before you're able to develop all of the background and do all to be able to do that. And these days, especially because computer science is quite popular in the universities, these programs have become quite competitive to get into, and also to just keep going from undergrad to master's to PhD should anyone choose to do that.
Mhm.
So I would say these are some of the challenges, but it's not, I would say, um, the the positive side of that is that compared to even, I would say, a few years ago, there's a lot of resources online. In that sense, computer science is quite is really great because you can learn any new concept by just getting on YouTube, and there are a
Mhm.
plethora of courses available online from many major universities. So it's quite easy to find a lot of the tutorials and the information that you need on most things.
Mhm.
So anyone can really get started if you want to go down that journey and just start contributing to research or just doing a cool project or even building a new company out of
Yeah.
some cool use case for AI or computer science. All of those things are within reach given how much information there is to learn, just available quite freely. So that's some of the positive things about that. And um, Other than other than that, I think now is a great time. There are lots of opportunities, and there's a lot that can be done. And as long as you're excited about the area, there's plenty of ways that you can get started in it, either through academia or just directly yourself as well. Just uh, based on what I just said, it's pretty easy to find resources online to learn
Yeah.
quite a bit.
Yeah, 100%. Thank you so much. And last but not least, what legacy do you hope to leave in the fields of computer architecture and systems, and how do you want to be remembered?
That's a great question, and it is I would say I think for all of us as researchers, we try to make an impact. So I'm hoping that my legacy is twofold. The first is in mentorship, um, because for me, mentoring my students and um, the students that work with me is extremely important. So I hope that a huge part of my legacy will just be that, which is in helping mentor some brilliant minds of the future who go
Mhm.
on to do great things themselves.
For
So
sure.
a huge part of this will be just that. And the other part is just like I've been talking about in the podcast, I do think computer architecture is a huge enabler for exciting applications. It has been in the past and currently is, and I expect that will be the case in the future as well. So I'm hoping during my research career, I can contribute significantly in that manner to be able to enable some exciting applications as well.
Definitely. Thank you so much for that answer. And thank you so much for your time and for sharing your incredible journey with us today. Um, I'm looking so forward to seeing your continued impact in the field of computer architecture and AI.
Of course, and thank you so much for having me. It was really great to chat with you, Berlin, and
Of
to be on your
course.
podcast.
Yeah, pleasure to speak with you. Have a great day.